which is collecting all the text from a particular column named text in that particular file we imported into R. So after doing that, the next thing now, which is fresh, coming from that, is to set up our sources and corpus and using these two codes, these two lines. So like I said, you have to install your TM package. TM is for text mining. After installing the TM package, you then load it into the memory this way. So if you do that successfully, the next thing is to now set up your sources and your corpus using this command. This is just my choice of word again. You know, this is my own. This climate source is mine because I want to set up a source. So this vector source is a function in text mining. This vector source is a function in TM. If your TM is not loaded, this function will not be activated. And how do you know whether a function is activated or not? When you are typing it in your console, as you are typing it, it automatically bring it up. As you just type vector S to bring the rest of the thing up, and you can accept it, which means you can see it already in your R. So our climate text, which is this, like our object, which we have created previously, it's coming from here, where we have stored the collected text, the collapsed text. So that is what we want to put in a source now. So, and this is the command for that. So after that, the next step is to also create a corpus. So by putting it, I like to use the name that is related to it. So climate corpus, then you use the word. This is also an internal function of TM, which is your v corpus. Meanwhile, this is you will now do v corpus of the source. So just bring that file here, put it in here, and then at the end of the day, v corpus will put it in a corpus and we'll put it in this particular object, object here. So you will now this is the object we'll be dealing with until we get to our final end. This is the object we'll be dealing with until we get to the final end. So from your end, I want you to do that. You want to do a vector source now, and then using your climate text. For me, I have it already, but that's fine. So climate, which is just a source, which is just a name of my own, you know, from my end. So you will now want to, like I said, you have to do your library TM. Me, I already have it on my system installed. I'm sure by now you know how to install. I cannot be telling you how to do that. So we want to do vector source now. You can see as I type vector, you can see all those ones. Vector, vectorize, vector source. So this is what we need. Vector source, our climate text. What did I use there? Oh, I have not done that in this place. I did not save it. Climate text. So I have to now, let me see. So after you have done that, you will now have this climate corpus waiting to be treated further. Within this corpus is like bringing all the text together in a single file. In a single file, it has already collapsed all those terms together. So the next thing now is, and with it, you find out that when you are doing in text, in Twitter tests, there are a number of things you will find there. You will find hashtag, you will find colon, you will find comma, you will find full stop, you will find white space, you know, space in between words. All of those things, you do not need them. And then what do you then do? All you have to do is remove things that are unwanted within your text, so that at least your text can be as clean as possible. Your text can be as clean as possible. So in this particular slide, what we're going to do is to do data cleaning. Data cleaning, starting from one of the prerequisites of text or the procedure of text mining is to lower all the upper cases of the text you can find anywhere, to lower them, to bring them to lower cases. So, and that is what this particular one is going to do here. This first line, climate corpus. Like I told you, we are going to be updating this climate corpus, which is a corpus here from here. Whatever you're going to do, you update it so that you continue to, it's like carry forward in accounting. Continue to carry it forward until you get to your final end. So here, this first line here, we want to use this function in our text mining package. TM map will be used to transform the contents to lowercase. Get me right? So what this guide is going to do is he's going to bring our climate corpus here. He's going to step it down into lower cases. This is what this guy is going to do. So this is a new name you have just created again, climate corpus. You see like a new name. But then, so this is the climate corpus that is coming, that is carried forward, which is the object you want to work on. And then what is that action you want to perform? You want to put the content transformer to lower. Content transformer itself is also a function in TM. So to transform the contents to lower cases, that is what that is going to do. So once that is done successfully, once you don't have any error, if you agree with me that it will just move to the next line, be waiting for you to respond. So the next thing is you want to remove the punctuations. You know, punctuations, what are punctuations? Comma, full stop, and all of that. Yes, that's what you want to do. So semicolon and all of that, you don't need them. So you also have to, as you do that, you're going to put the update of that file within the climate corpus as well, so that continue to up, because at the end of the day, what we need is this climate corpus that we want to do something on finally. So now what you're going to do is use your text mining map function again, which is an internal command in a TM library. Still working on our climate corpus, which is carry forward. Also do strip white space is also a function to remove white spaces, also within the same climate corpus. So this climate corpus now is still referring to the previous one we just created, bringing it here, creating another one. So then you want to also remove words. Well, and what are those words you want to remove? We call them stop words. Stop words in English are something like a, the, and, for. All of those things, they do not really have any meaning, but then most of the time we use them to join words together. We use them to join words together, and so that we can have a better understanding of text. But in this environment, because what we really want to do is to do a kind of a content analysis of or description of your words. You can also do the same thing for a thesis, as big as that thesis is. You can bring it together in a corpus and then look for the most frequent words in that thesis. And this is one of the things that people use when they are doing, and this is one of, let me tell you, this is one of the technology that you can use to automate marking of essay writings, which ordinarily is still a bit difficult now to do. But this is one of the technologies you can use to automate. Ordinarily when people do what do you call it? This ABCD, multiple choice. Multiple choice is very easy for computer to mark, but people have been finding it difficult to mark essays, such that when you can give a test now online and you ask people to write text. Take for example, you have 5,000 students and you want them to respond in essay type. So how do you then mark it? Are you going to be opening one by one and be reading it? So that would be laborious. But then a way to doing that is to text mining is one of the things we're going to use to automate essay marking. So that's one of the benefits. So the next thing now is going to remove the stop words. Stop words in English is in a dictionary. in a dictionary which is called stop word. So all those words are loaded there. So every word that is in that dictionary that exists within your corpus will be removed because we don't need it. We don't want the system to count that as part of our terms. So then the next thing is to remove numbers. You know, you can say you can put 1, 2, 3, you can put 10, 20, 525. You don't need all those numbers. We don't need them for our text analysis. We don't reckon with them. So we also remove numbers that exist within that corpus, and that is why everything would then be archived in our climate corpus. So that is what you also carry to the next thing that we have to do. So the next thing we are going to do is to do a kind of a document term matrix. Document term matrix. Let me quickly, I want to use this single slide to explain what a DTM is. A document term matrix is a mathematical matrix that describes the frequency of terms that occur in a collection of documents. Frequency of terms. Terms means words. Like if I say Jesus is Lord, Jesus is a term, is another term, Lord is another term. So a document matrix would want to look at that your entire document as a whole and say how many times does Jesus occur, how many times does another term is occur, how many times does another term Lord occur within that document. So in a document term matrix, rows correspond to documents in the collection. And you know, if you look at this now, this is doc 1, this is document 1. Within that document 1, how many Jesus, which is T1, occur within that document 1. Document 1 may more or less like represent the tweet of a single person, one single tweet. That's a document. Another tweet is another document. Another tweet is another document 3. Another tweet is another document 4. So is that saying that within that tweet collection of text of one single tweet, how many times does a term, given a term, say Jesus appear, which is T1? You can say another term, say T2. How many times does it occur? You can say, okay, you can then number it. So the system, the document terms matrix will count itself of those terms. Depending on the number of terms that exist within that corpus, it's going to list those terms this way. It's going to make a list of those terms as it is now from left to right. It can be up to 1,000 words. It will generate it by itself and list it. And then on the other hand as well, it's going to list the number of documents, the number of cases that you have, and then do this matrix, do the calculation by itself, and that is what this particular term is going to do. So that's what this internal thing will be doing for you. That's what will happen internally as you do your DTM, which is document term matrix. That is what the DTM will be doing. So this DTM is our own chosen name. It can be anything. The function that will be carrying that out is our document term matrix, which is this function. That's what that function will be doing. So, and then what do we want to work on? We want to work on that particular thing. We want to work on our climate corpus. Don't forget what we are carrying forward. That's our climate corpus text that we're carrying forward. So that's what the DTM now is going to do, the document term matrix, which is also an embedded function of TM, text mining. So once you do that, fine. So the next thing for us is to now convert it to matrix. You know, to convert it internally to matrix. So, and how do you do a conversion? I think we have a bit of that. You can then call it DTM2, which is another name of our choice, to convert our DTM, which is coming now as matrix. See it as matrix, as dot matrix DTM. Don't forget to close the bracket here. There's an error here. Close the bracket here, DTM. You close the bracket. So that is that. That means we are good to go. So the next thing now is, since that table has been generated by this, which is stored in DTM2, you know, this table is already generated, stored in DTM2. The next thing for us now is to look at the frequency. What is the frequency? Do column sum of that frequency. You know, once you do the column sum, let us see the frequency of the terms. That is what this is going to do. We are familiar with this column sum. It's going to do the column sum and then see the frequency of that. Once you have this now, the next thing now is to do a live a word cloud, which is like the chart building. You want to see the word, the word cloud at a glance. What do you have? So this command will give us the word cloud that will be generated, will give us the word cloud. So, but then, like I said, you must have installed this word cloud, the package word cloud. So you must have installed the package word cloud, and then you invoke it by the word library word cloud. So once you have this, you then bring, don't forget, you already have this word, all of these things put inside words, and your word is coming in here. But then you want to do it in such a way that it will display the graph. It's like a chart anyway, if you like. It will display 100 words of that chart using this order, and then using this column. So once you have this, you just wait for it to generate your graphs for you. So I want you to go back to your, do you have any question up to that point? At least we'll do the answer together now. At least I've described what each of those things are doing. So if at the end of the day we couldn't finish it with the network, then we know that we are covered with what I've explained. Just follow that procedure and we'll be fine. So, but then let's see. Any questions so far, so that we can do it together. Any questions so far? Load the data set into R. Are we there? Can we see that? Load the data, that's the heading. Text reach.csv climate CSV. So, are you there? Or nobody is practicing with me? You are not demonstrating. Are you working with me? Are we together? Okay, so I have done it from my end here. Text.csv, so I have that. So I have my climate text there. So the next thing now, it's I want to do my source now. Library TM. I have my climate text. So vector source. Can you see that? I put my climate text inside, and then I put it in a place called climate source for the purpose of uniformity. So you can see that, accept that. Then the next thing is to do climate corpus. So we use v corpus. That's the command, and then you put it inside of climate source now. Climate source. And then you put it in a container called climate corpus. That's fine as well. So I have climate corpus now, which is already done. So the next thing is to begin to do the cleaning, which is yes, we want to do cleaning. The first thing is to lower it into a lowercase. Let me copy so that to save our time. To copy it into lowercase, which is done already. Now it's already stored in our climate corpus. Don't forget. We want to now do the same thing as well again to now remove punctuations. Like I said, your remove punctuation is a function. TM map is also a function. So I'm going to do that as well here. You will see that. If I just say this TM remove, and see, remove numbers, remove methods, remove whatever, they're all there as TM function. So the remove function is also there, like TM function. So my climate corpus have removed punctuations successfully without any error. That one is also working. I'm also going to remove my white space as well. Look at my white spaces are also well removed without issue. I'm going to remove stop words now. Now I'm doing it one by one because I did not bring it inside the. I can always create the script here and put everything together. So that's what I want. That's the assignment for you. So you're going to match them together, such that once I plug in any text with a given name, I can automate it. So my climate corpus is ready. So the next thing I have to do what to do our DTM. The DTM here, which is the document term represent. I'm going to do this document. Can you see? Once I click on that document, it will bring it out for me. Oh, are you thinking about this? And then you can accept that. So what do you want to do? Your climate corpus is already there. Then don't forget to store it in where the DTM. Yeah, it's successful. So the next thing is we want to also convert it to matrix DTM2. I'll say DTM2 as dot matrix.
DTM.
Yes, and DTM is fantastic. So that's because that's where you stored it.
Yeah.
Done. So my DTM2 is done. DTM2, if I do DTM2
Load.
and press enter, and see all my documents is giving me all the documents. I just loaded DTM. So DTM now has broken everything into documents, just like we have in this place. See, like we have here. It has broken into documents, which is what we have here. Can you see? Document, and some of them.
It doesn't appear to show like the table in your after your command now.
Don't worry about the table.
Okay.
This is the table is an explanation, but you are still going to see. You are going to see. It's going to do. The table is useful for counting. So you will see it now. I will show you. You will see the counting now. So the next thing now after. So the next thing now is we want to find the most frequent term. Those terms, each of those terms, it will look for you which one is the most frequent. So that's what this is going to do now. So I am going to do column sum of our DTM2. And we have that. It's already done the column sum, column by column, to sum them which one is more. So it has stored, and it's already stored in frequency. So let's see what we have in our frequency. Can you see? Those terms are there. Your frequency now, you can say frequency. Let us summarize the frequency. Summary frequency. What do you have? You can see the summary of that frequency, which is like the minimum is 1. The first quarter is 1. The median is 1. The mean is 5.63. The third quarter is, so the maximum counts for a given term is 1957. So which of the term is 1957? Let us do add frequency. You can see, well, these are the ones that are, this is not in any particular order now yet. So the order of increasing frequency or decreasing frequency is not yet there. So that's what we want to introduce now using the next code, which is now help me sort it in such a way that at least I can, the most frequent ones can come up first. That's what this will do. Then you can then do your frequency again. Frequency. Oh, this is fine. But then I want to see the edge now. Edge frequency. Yeah. I can see very clearly now that our climate change has 1957. Climate itself has 621. AMP, which is ampersand, 540. Sustainability, 439. Report, 406. Will, 374. If you want to see the tail, the few ones, and if you also like, you can view it, view frequency. That can be displayed here, and that is what you have. So as it is now, that is what you have. Transit climate change 1957, climate 61, AMP 540, sustainability occur 439 times, report occur 407 times, will occur 374 times, change occur 342 times, impact occur 335 times, and so forth until down. You can see that is in decreasing order. This is 2, and so forth. So the next thing, which is to do a summary for us that we can see on the screen. So let us put this one into words. So we'll now use that word to plot our, like I said, don't forget to do library WordCloud, because I've already installed it on my system. If it is not installed first, you have to go and install it first before you invoke it for use. I'm talking about WordCloud. WordCloud is what will give you this chart we want to produce now. So this particular line will produce our chart for us. Like I said, I have explained that it's to give us, to just use 100 out of those words to display the results for us in a graphical mode. And then you should be expecting the result here. There you go. Can you see from the end?
Not yet.
You cannot see this.
Yeah, another quadrant rather.
That is it. So if you want to change this color, which color do you want to choose? Which
Let's
color
see
do
green.
you want?
Let's see green.
Fine. Okay, 2 seconds. Expire. But this one is not obeying my command. That's why I said some of the time copy and paste from PowerPoints may be deceptive. So, but can just be a guide. That's color green. Which color again do you want? Red, Abby? Or blue? No, I think we used blue the other time.
Yeah, I'm trying to see one bit green. I can see the what you added to it, the colors green, that made it green.
Yeah, that is it here. It's very obvious here. Colors, we see colors green.
Then yeah,
so,
it's okay.
It will, you know, it will use the number of frequent words apparently. If you look at this one, AMP, it's a bit more prominent. Sustainability is also prominent. Impact is also prominent. Report is also prominent. Change is also prominent. COVID is also prominent. I'm sure you are familiar with this WordCloud. You must have seen it somewhere before. I'm possibly wondering how did they come about it. So this is how to get it done. And let me see. Maybe I can. You can also. I think you can also use this hexadecimal code. Hexadecimal. Let me use. 336699. I think this is like this Yahoo mail color. So, but let's see. Worked. So you can also use hexadecimal.
These warning messages, there are too many. It's just like, you know, it appears like, oh, the usual error sign that one will see when one makes mistake.
Come again.
But they are just warning messages.
Which one?
The warning messages that are coming with your output. Okay. They are just warning messages. Really, they are different from error signs, error messages. Must they come?
Which one is that? Oh, all these ones.
Warning. Yes.
Oh, don't bother yourself.
Of course, one shouldn't bother, but then you know it's a replete of those error messages like shame mistake.
No, there's no mistake. Once you have your output, some of the time,
course, I understand. When it is warning message, it's usually different from the errors. Yeah.
Because if you look at it, say climate change could not be fit on page. It will not be plotted. At the end of the day, the thing was plotted.
It's okay.
So you can apparently export that. You can save it as image. You can also save as PDF. You can copy to clipboard and go and paste it in your Copy Plus, in your Microsoft Word, maybe where you are reporting. You can come here to paste. It is immediately handy and useful for you. You can paste it here. And then you can expand it like normal, what do you call it? Like a normal, you can centralize it. You can also crop. Also crop and then expand further. So that is that. So that at least you can see it bolder. So that is what you have, and that is what we intend to achieve tonight. So I want you to go back, repeat the same procedure, and then try to automate that so that you just put your code in a single file, and somebody can come there, just say everything should run from top to bottom, and it should give us that. So that way you know that you already have a text mining code that can harvest text from a given data frame and then produce a word cloud. So that is that. Do you get the assignment? I'm going to flip it here again for you to see. So put your code, put your R codes together to automate the process of text extraction from a given data set, and let it end in plotting a word cloud.
Oui, hello.
That thing I showed you here that we generated is referred to as word cloud. So let's go back and do that. Any question? That is where we're going to end tonight. That's where we're going to end tonight. So hello, any question? You can talk now. That's where we're going to end tonight.
Mine is
sure
rather
you
a request.
What you have done. Okay.
Hello, a request of about 5 to 7 days for submission of the assignment.
Yes. I know this shouldn't take you 1 hour. It shouldn't take
yes,
you 30 minutes.
Getting the time to come inside and do it is the issue. Hey, I know you understand. Hey.
I don't understand.
that I even attended the class tonight. I'm very amazed at myself.
But the truth is, you find out that the course that you need, they're already there with you now. I've already given you now.
Sure, now it's just a matter of copy and paste. It's to load.
No,
but I think I had initial problem loading some of it's okay. I think initially I had some problem loading some libraries when I was installing. I'm not too sure what I would be seeing now. Now that I need the TM library particularly. It's okay. We'll give it a try.
Oh, any other question?
Yes, sir.
Okay.
Hello, sir.
I'm with you.
Okay, thank you very much. It's not a question I have for the class, but is some suggestion I would like to put. When we were introduced to text mining, I thought that we'll see things like how to build references from an article, how to use R to do that. Those should be things we will see. And also
references, wait. References from an article, what do you mean? That's not text mining. That is just a automating citation, is that not?
Yes, something like this. Can R help to do that?
No, that's not the work of R. We have simple packages that can do that. Zotero can do that. Mendeley can do that for you.
Yeah, Mendeley can do it. I thought that in R we can also do it.
No, it's a waste. It's a waste of R energy. I'm telling you, it's a waste of R resources.
It's so much super for that.
That's word processing.
Okay. When we were talking about word processing, I thought that those are things we will see.
No, that's
So
not text mining. That's not text mining.
Okay. Apart from that, I also finding that we have at least on, let's say, 2 or 1 class again for for our programs. So
yes,
we started the econometrics before. We did not move forward. We just did 1 class, and then we said we see other things, how to plot, how to do some
plotting
other.
is what we are doing next week. I just told you. I told you that.
Okay.
We are doing plotting next week.
Next week.
Okay,
is what I want to.
That's our last class.
Okay.
That's our last class.
Okay.
But what? Find out that already. I said that before I even opened up the space for interaction. So we're going to do plotting next week.
Okay.
So relax.
Okay,
So,
sorry. Let me say. Can I say something, sir?
Free.
Okay. Interestingly, I know of some other qualitative data analysis package that will just do what we call text mining now, the WordCloud, with just a simple command, like in maybe atlas.ti, for instance. So, but then it is very interesting in how coming by this true series of codes, but just a simple command, just like one would do, like maybe under expresses, for instance, just go through a command, get the text, click on WordCloud, and then it just brings everything now with the frequencies, the most occurring word, the least occurring word, and things like that. So I think it's just an evolving area. Qualitative data analysis, as how does that, some other packages are also evolving and doing something similarly wondrous.
Well, there are a number of packages that can do it, but they're not free. That Atlas you mentioned is not free. You have to pay for it.
Sure. That is what stands R out. This is just what stands R out.
So,
yeah, sure.
So that's why.
Atlas it's very, very costly. Very, very costly.
We have rapid miner. We have a number of them like that. But
in vivo and some others too. Yeah.
In vivo is about $2,500 or even $3,000 if you must have.
Wow, it's even costlier than Atlas. Atlas is just $70, I think. Yeah.
Yeah. So it's a bit expensive, and then
so definitely that stands R out. Yeah.
Exactly, and then even that's for the lazy ones, because you do the thinking by yourself.
Exactly.
Give it to you. So and then if you are now telling anybody that you're a data scientist using those tools, they won't reckon with you, because if you know how to use Atlas, you are not a data scientist. You are just an analyst, somebody that can just analyze normal
qualitative data analysis.
Just thank you. That's just what you are.
Yeah.
So those are. I mean, you can't. No, some of these software cannot beat R and Python. But for me, I'm cut out for R apparently, because R will not bother you. Will not give you too many codes. But Python, what you will do with 1 line, Python will do it with 5 lines. So why don't you just stick with R? By the time we are doing the graphing next week, you'll be surprised. Only 1 line.
But is there really something that one can do that the other cannot do between R and Python?
Is there
something that perhaps that Python can do and R cannot do, or vice versa?
Well, they claim that Python is it's more memory friendly in terms of you can manage your memory better than R.
Okay, in terms of space or something.
Yes, please, yes. So
that isn't an action anyway.
Okay, but it's fine. It's fine.
I think I'm more convenient with R too, really.
Yeah. But then
I find it difficult starting all over with Python again.
No, you can also explore it, but
let me try and master this one.
All right, that's fine. Thank you to everybody. In the absence
it's okay, thank you very much. It's been a wonderful class tonight.
Thank you so much. So please, your assignment is due in 5 days or thereabouts.
Thank you very much. I hope the reminder will come on the platform, the due dates. Yeah, thank you, sir.
Special grace of God, we're going to do graphing, and then we'll be fine for the program. So all those people that also showed interest for the other aspect I said I was going to introduce you to, I think
Yes.
and then as many people
More
as
data online, right?
exactly. So as
Okay.
many people as being interested, I'm going to bring you up tomorrow in a chat like this so that we'll get
Okay.
started.
Okay.
So that there is a kind of a coding I want us to do, which you will see how it is done. So if you have time during the day tomorrow, I'll put the meeting link on the platform, and then we can meet, say, around 10 a.m. So that we'll
It's
just
okay.
chat for about 30 minutes and we'll be fine. All right. Thank you. Have a nice
It's
rest.
okay. Thank you.
Thanks.